Welcome, everybody. Welcome at the session where we are going to talk about production excellence in machining and the role of operators in the machining process and how the two come together. This is the fourth session in a series of 5 on tooling. We had several sessions before, and this fourth session, here we are kind of entering reality. The 3 previous sessions were more about preparation and stuff. Now we enter reality. That's why operators start to play a role now. And as always, it's not just me. I have 2 colleagues, or perhaps in the meantime I could say friends here together. That makes things from a technological perspective all possible in the background. And this series about tooling, smart tooling decisions, it says, we had a part 1 where we talked about that tooling is not a detail. Tooling is something very important when you talk about a machining production, despite the relatively low purchasing costs if you compare tooling with the other elements in production. Tooling is a very important thing, and we had a session on trying to show that by examples and stuff. In part 2, we talked about the role of management, a very important thing, and especially important as very often from a management perspective, there is a tendency to kind of push decisions about tooling towards engineering, towards people in the workshop, which is, allow me to say, not the best choice, because management has to take a role in everything about tooling. The role of management is to decide on the overall strategy about tooling in a machining company. What is expected from tooling? How should tooling contribute to their overall company or business targets of the company? That's the role of management, of course. Once that has been decided, in part 3 we talked about, I call it engineering, but you could call it production management, you could call it programming or whatever. My generic name is engineering. Engineering is the department and whatever happens there. But engineering is a department where decisions taken by management about strategy are translated into practical stuff, in a sense of, okay, which tools exactly are we going to use now in the process? Which machining strategies are we going to use? How are we going to organize things in production, and so on? That's the role of engineering. Engineering takes strategy and translates it in such a way that production fulfills or contributes to the overall company targets. But so far, kind of, it's all on paper. Nothing happened yet. And now in this fourth part, we are going to talk about execution. We are going to talk about, okay, we have a strategy. It's all translated into technical stuff. And now we are going to apply it in reality. And that is where operators step in. Now, operators have to take their responsibility in the total process. And what we are going to talk about is, okay, what exactly is the role of a professional operator in this presentation? This is not a technical education. This is not a technical course on toolware. This is not a technical course on machining strategies. This is a course on, how should I call it, operator attitude, operator behavior in that full picture of production in a machining company. And perhaps some of you have some doubts now, because we started to talk about tooling. Part 1 was about tooling is important. And now suddenly, it started in the third part where we had we talked about engineering, and especially now when we talk about operations in a company, we talk about the machining process. And some people say, yeah, wait. Is it about tooling now, or is it about machining you are talking? Well, somehow tooling became the machining process. And you have to see it like that. Take an airplane. In the beginning, you have people talking about the jet engines, and you have people talking about the landing gear, and you have other people talking about the structural parts in an airplane. And all of that is important. And all of that needs to be well designed and needs to be in line with specifications. But somehow, everything comes together in an airplane system. We have an airplane. And we started to talk about jet engines, tooling, and suddenly we talk about an airplane, a machining process. And you know that is how it goes. And that, by the way, is also why tooling as such from the beginning is so important, because whatever you decide about tooling in an early stage is going to have serious consequences in the machining process. And we have been talking a little bit when we talked about the engineering part in the whole picture, that we said some of the problems, or perhaps even a lot of problems we have during machining, find their origin way back in time, where management, for instance, was deciding on a strategy. So tooling transforms into the machining process, which contributes to the company targets, the business targets of the company. And in a fluent way, one turns into the other. Now, the responsibility of operations, as we call it, operations is everything that is around the workshop that make things happen in reality. The responsibility there is that execution makes performance. So far, performance, production excellence, whatever, was on paper, was in a planning phase, was designed as we would like to see it. But once we enter the workshop, then it's becoming reality. And at the machine, with other words, operators, what they are doing is kind of guiding theory into reality. And that means that operators have, from that perspective, a rather broad task. They have to apply decisions which are taken by engineering or by management. They have to monitor how the process goes. They have to react when there are variations happening in reality. And the fourth part, perhaps the most important one, even if there are in real life variations that modify things, they have to try to make the process stable. And that is a major task, because it's a constant task. It never stops in time, because a production environment is never, ever perfectly predictable. We see in reality that there are variations in the material properties, workpiece material properties, the hardnesses, the stuff like that. There are different machines, there are different setups. You can't just take a process from machine A, put it on machine B, and expect it to run as before. Machine setups are different. There can be unexpected interruptions, disturbances in the production. A tool is supposed to be there and is not there. Yeah, then what? And there are constraints, practical constraints, that perhaps are not always visible during the planning phase. Take the example of a temperature in the workshop which is too high, what we had last week in these parts of the world. Temperatures were much too high. the temperatures in workshops were higher than what is kind of normal in Europe. And that leads to unforeseen things. And in that respect, you have a reality that is not fully predictable. You have a reality that is modifying, changing all the time. The role of the operator, one could say, the role of the operations department as a total, not only operators, but also people working in the tool crib, quality control, all of those departments, is to make sure the system is stable. We can't have a situation where the outcome of a machining process today is 2 workpieces and tomorrow is 3 workpieces and the day after is no workpiece. We have to stabilize that. And I would like to put the word stable opposite to optimum. Because for a lot of people, when you talk about machining, they think in terms of optimized machining. Whatever they mean, but optimize the best possible in certain circumstances. I put against that stable. Machining should be a stable process, a reliable process, a predictable process, a controllable process. And if we have that, of course, in a second phase, we could start thinking in optimizing. But it's like sports people. It's not about having one exceptional game and that's it. You have to bring in stability in your sports behavior, in your sports performance. It's only as that you can win in the end the championship, not just by one exceptional game. Machining performance in the context of production economics is heavily depending on stability. If you don't have stable processes, the outcome is insecure. You never know what happens. And everything we have to select in machining, the tooling, the strategies, the methods, the whatever, should be first of all supporting that stability. Because if you have stability, you have stable tool performance, you have reliable production flow, you have stable production economics, you have a sustainable production system, whatever. You have things running under control. And operators, to achieve that, they play a key role. And in that respect, I don't know if there are people from management listening in here, but unfortunately for some people in management, an operator is a button pusher. The operator has to put in the workshop, close the doors, push start. No. A real operator in whatever situation is the person, is the element in production, allow me to call it an element, that influences by attitude and behavior seriously, heavily the stability of the process. And operators, to create that stability, they have to make sure that the setup is correctly done. They have to handle workpieces. They have to handle tools as it is supposed to be done. They have to monitor the process. They have to be kind of a sensor to see if the process is running stable, if the tools are performing stable. And very important, the part which is sometimes a bit problematic, I'm coming back to it, they have to give feedback. An operator, as he's sensing reality constantly, is also the first in line to give feedback to engineering, to management, about how is it in reality? How are your plans performing in reality? And if that is the role of an operator, if an operator needs to be capable of handling things in a correct way, if an operator is supposed to monitor the process, the tools, see what's going on, and if an operator is also responsible for giving feedback to other departments in the company about his observations, the question is, What makes somebody a good operator then? How do we define a good operator? And production excellence, heavily depending on operators, as I already said, because they are the ones making theory function in reality. So production excellence, heavily depending on operators, and we need for that good operators. There are three pillars that makes a good operator. And these three pillars, I would say, for management is a key element, because a good operator needs education, needs training, and needs, I don't know, should I call it motivation, of mindset, whatever. And if we have these three in place to support the operators, if we have educational support for them, if we give them the opportunity to train things, and if we make sure they have the correct attitude, then we have a fully professional operating operator. Education needs to give, or education, we need to give operators knowledge. And knowledge, they need to understand the whys. If they see certain types of ships, they need to know why does a ship looks like it looks. If he sees when he's preparing the machine for the next job that certain tools has been selected, that certain machining strategies has been selected by engineering, he needs to understand why engineering decided that. Why did engineering decided to select this set of tools? If there is instability during the process, he needs to know why that instability is there. All these whys, understanding management decisions, understanding engineering decisions, understanding the process, and understanding why certain decisions, why is the process performing as it is, that knowledge people are not born with. We have to share that knowledge, and that's what I call education. Once that knowledge is there, operators need skills. They need to know what to do if something is not in line with expectations. We expect a stable process. The operator sees that there is instability in the system. The operator, based on his education, knows why that instability is there. But next, he needs to know what to do and how to do it. That's what I call skills. And for that, operators need training. So, how to mount tools, how to act when certain wear patterns are appearing on tools. And this doesn't need to be negative. It can also be just, okay, what I see is what I expected to see because I know why. So the correct action here is don't do anything. Because too often machining people, they sometimes see problems where there are no problems. They see the tool wearing out and the tool is wearing out. Yeah, of course the tool is wearing out. Not all wear is bad. A lot of wear is a fact of life. And training makes that an operator, from an operational perspective, performs well in a reliable way, and is doing things in a repeatable way. Repeatable is also an important word, because if a certain phenomenon takes place today and somebody decides to action A, and tomorrow the same phenomenon happens and somebody else decides for action B, and the third day action C, that is not good, because that means that in the company there are different opinions on what to do if certain things happen. And again, stability is what I'm after, and stability also demands that fact A leads to response A and not A or B or C or D, depending on who is taking the decision. That's skills. That's what should I do in a certain situation? Perhaps I should not do anything. Again, it's not always negative. It could be, okay, what I see, I expected to see, so everything is okay. What should I do? And if I need to do something, how should I do it? If something leads to, okay, this tool seems to be not okay for this job, so kind of I take the decision to change the tool. Okay, change the tool, but how do I change the tool? What do I change on a tool? Is it a carbide grade? Is it a geometry? Is it a nose radius? I don't know. So not only what to do, but also how to do it. And the third part, and basically this is what this presentation is about, because the first two ones are technical educations, technical trainings, and as I already said in the introduction, this presentation is not about technical trainings, neither education. This is about mindset. This is about attitude. This is about behavior. And what I'm talking about is that operators, imagine they have all the knowledge they need, that they want, and they have it in their fingers. They have the skills. They know what to do, how to do. Then it's yeah. What do they decide to do with that? And that is about discipline. If in a company, and there should be in every company, but anyway, if there are SOPs, standard operating procedures, which describes what to do in a certain situation, an operator, a professional operator, has to have discipline to follow the SOPs and not to reinvent each time again different procedures. When there are SOPs, an operator should show the discipline to follow them. An operator also, this is a tough one, should be willingly to ask support. The average machining operator is a very proud person who does not like at all to ask help, because that is a bit hurting. However, a professional operator should be willing to ask support, help when needed. And the when needed we are going to define within a couple of minutes. He shouldn't be ringing the bell every 10 seconds, but sometimes when it's beyond his responsibilities, he should be willing to help. And that brings me to responsibility. What is his responsibility in everything? Is his responsibility to optimize the machining process? No. His responsibility, his first responsibility, is to make sure the process runs stable, so that management can rely on that the targets they have been putting forward are realized. Stability also reassures engineering that whatever they decided from a technical perspective is executed. And if engineering decides to go for high feed milling, they should rely that high feed milling is what is applied and not that the operator decided to go for high speed milling. Because of course then the outcome will be different from what was planned for. And an operator also need to show commitment. Commitment for teamwork. Engineering is there to support when needed. So the operator should be willing to cooperate with the other departments, should show commitment also to that. And also commitment to give feedback. And that feedback, there's a complete chapter in the end where I'm going to talk about feedback, because that's a bit of a tricky thing. And you know, this knowledge is rather simple. Sit down, listen, and I educate you. I give you knowledge. And training to achieve skills is also easy. Do it and do it again and do it until you learn it. But machining culture is very much based on independence, personal expertise, personal proudness. And if you look now to these 4 words, discipline, willingness, responsibility, and commitment, it could be a bit, could lead to some discussions, let me put it that way. Although if it's there, that's the moment you have reliability, predictability, and you have a stable process. Now, Imagine management did what it's supposed to do, made sure operators have the knowledge, have the skills, they work on mindset, on motivation, and all of that now in daily work. What does it mean? It means, first of all, that we have to realize that reality in a workshop is not always following the plan as was made by management or engineering. How good the preparation is, reality in machining could be that things are different, and so tools or the machines start to behave different from what is expected or was expected. And again, this is due to material specifications that can show variations, machines that are different, in unexpected disturbances and things like that. So whatever planning, whatever preparation, very often reality will need some adjustments. And for that, operators need continuously to observe a machining process. Especially from a technical perspective. How are the ships formed? How does the machining process sound? Are there vibrations? How is toolware developing? Which type of toolware do we see? How is the quality of the finished parts? Is it what it should be? And so all of these things is what an operator actively have to observe during a machining process. And you see, that is why sometimes I have issues with people saying, an operator, as long as he knows which button to push, we are happy. Active operators, and those are the ones that will help a company seriously to achieve production excellence, because once again, production excellence is realized in reality, not on a drawing board. Makes that operators needs knowledge, needs skills, because it's not only about watching the ships and the wear and so on, but it's also to which interpretation do they give to what they see. They see a certain form of ship, okay. They see a certain wear pattern developing on a cutting edge during the process. Okay, they see a certain surface roughness appear. Okay. But the interpretation, and this could be what you see here in the rectangle, a core mission for an operator, because he observes, he sees, and then he needs to take some serious decisions. He needs to decide what I see convinces me that this process is running stable. With other words, reality, theory, practice, preparation are in line. Everything okay, don't touch anything, let it go. Or he could see that modifications are needed, but it's minor modifications. It's things perhaps reduce the feed a little bit, and things are every tool is different, and okay, minor modifications stabilize the process. Fine, he should make those modifications. He should be capable of knowing what and how and why he does it. Or He recognizes that the operation is not stable and minor modifications won't do. Major modifications are needed. That's the moment he needs to decide, okay, it's time to take this situation up the hierarchy. The situation should be escalated into engineering, perhaps even onto management level. So whatever an operator is observing during a machining process, I see everything is stable, fine, don't touch it, leave it alone. Which could be a challenge also, because a lot of operators, they like to optimize and tweak and stuff. If it's running in line with expectations, let it be. Or I modify minor stuff to make sure that things are okay. Or I see major things. I see things going kind of out of hand. Now I need to take it to another level. That's a basic decision every operator, by means of speaking, every second of the day needs to do, needs to make in his head. Whatever he sees that the process is unstable. Unstable doesn't mean there are vibrations. Some people think, if you don't have stability, you have vibrations. My definition of stable here is that it performs in line with expectations. And it does it all the time. That's what I call a stable process. If he sees that is drifting, his first action is to make it stable. Don't wait and see what happens in the long run. If an operator waits till the tool breaks, and if the tool breaks, you ask him, and he answers you, yeah, I saw it coming, that's wrong. The moment he sees, he needs to act. And act is not, again, optimizing. It's not about finding maximum performance. It's making sure that the outcome is in line with expectations. You know, if you play a football match, the target is to win. It's not with 5-0 or something. Win. 1-0 is also good. That's the target. And that's what professional operators do. A professional operator, having the knowledge, having the skills, having the mindset, the motivation, makes adjustments to stabilize the process. And stabilizing means controlled adaptation. It means if small variations occur, that he counteracts them to make sure the process goes back in line. That the within limits, the machining process is performing in line with expectation. And a very important line there is that the logic which was developed by engineering, selecting a strategy and a tool set and cutting conditions, that logic is respected. A professional operator is not there to reinvent the process. Making large changes, changing high feed strategies into high speed strategies, changing all the tools which have been selected, that is normally not the role of an operator. Professional operators modify, but very carefully. They know the difference between modifying to stabilize or reinventing the process. Or redesigning the process. Because when I say respecting engineering intentions, definitions, decisions, engineering has had a way of thinking. They were given management objectives. We expect from production this and this and this and this. They took that, they translated it into technical stuff. That technical stuff was then communicated to the workshop, and yeah, the workshop's responsibility is execution. If, however, it seems that it's not really performing well, a workshop, the people in a workshop should stabilize, avoid unnecessary changes. If things are in line with expectations, let's go. And if things are asking for more serious modifications before doing it, it's about communication. They should start to communicate with engineering, say, okay, your plans were this and this and this. I'm in reality, I see now this and this and this. It's very different. What do we do? But this, of course, demands, and that's why I said operators, but also engineers should be open to teamwork, because very often the reality in what you see is that unfortunately engineering and operations are a bit contradictory, Operators, engineer, they don't know, and stuff like that, and engineering, they don't do all the work fully through because they say, the operators will change anyway. It's an unfortunate situation, and that brings me to the feedback thing, because everybody in a company should realize that operators are the first ones to see reality. Management made strategic decisions. Engineering did, one could say, tactical decisions. What are we going to do? How are we going to do it? Which machining strategy, which machining methods, which tools, and so on. And then things comes in reality, and the first ones to see that reality are the operators. That makes them extremely important. Because they will see things which during a planning or a strategic session were not on the table. Tools that wear out in an unexpected way. Workpiece material that was supposed to have a hardness of 200 Brinell and suddenly has a hardness of 300 Brinell. The machine is vibrating due to whatever. Operators will see that, will observe that if they know what to look for. And that means that their observations are very important for the company. It also means that operators should not keep their observations for themselves. They should communicate that to engineering, to production management, tool management, general management, whatever they observe in reality in the workshop, good or bad, somehow should be communicated to the people who were in the preparation phase. And good feedback, objective feedback, feedback based on a well-educated mind is going to help the organization a lot. To make future improvements on machining, to make better tool selections in the future, to prevent that certain problems are coming back and back and back again, to stabilize production performance, not having today very good, tomorrow very bad, and we don't know why. In that respect, a lot of people like to talk in an organization about continuous learning. Well, continuous learning in a machining company starts with the operators. They observe reality. They should communicate what they observe. And everybody should learn from that and adapt things based on that. And again, whatever an operator observes, it's or the process is running fine, or the process needs minor modifications, or the process needs major modifications. Escalation of things will prevent hidden problems. Because there are much too many hidden problems in machining companies. That's at least my experience. I heard it so often working with people in a workshop or in engineering that they come up with that tools break in that operation. I could told you before because it's each time like that. Each time that tool breaks in that operation, and if something happens. things should be signaled. If in the end machining conditions that are applied are completely different from what was planned for, that should be said. There should be operators should ask for engineering support. I already said that when needed, ask engineering. Uh, Things should be reported in a structural way, not by coincidence during the coffee break. Ah, by the way, that tool broke. And if things are recurring, coming back regularly, that should be identified and tackled from a tactical perspective. And that communication, that escalation of problems is not a sign of weakness. Because sometimes operators, and I have to be honest, I sometimes had also that attitude. If I ask help, that's kind of a sign of weakness. He doesn't know what to do. It's not like that. It's yeah. Sometimes if you see that something is so much different in reality from the preparation, that you have to inform people about that. And that brings me a bit to, I call it, when strengths become risks or weaknesses, because a professional operator, if we go back in time and if we see how machining and people in machining, how it evolved from the past into the present, into the future, a good operator, a good machining expert is independent and shows personal responsibility for the process, is involved, with other words. He's a technical, very proud person. Look what I can. Look how I can handle cutting tools. I'm good in this. And he is persistent in solving problems. Sometimes I think that people are proud in their problem-solving abilities, but not so many people try to be very capable in creating situations to prevent problems. But that's in the next session, I want to come back to it. How to prioritize. Problem solving is not a priority. Problem solving is like the fire department. In case of, but avoiding problems is much more important. And if you think about these things, I'm independent. I show personal responsibility. I'm proud on the work I do. I'm persistent in chasing and solving problems. And if you think back what I said a couple of slides ago, communicate, willingness to work together, show responsibility to contribute to the overall picture, you understand there could be some tensions there. I'm independent. I know what to do. On the other hand, I have to ask help. It could, yeah. And that tension leads to that operators often start personal optimization programs, which is as such as a thought exercise very good if they communicate it with engineering. So based on this and this, I think that this and this could be possible to improve the process. Then it's fine. But if you do it on your own little island and don't tell anybody about what you are doing here, then it's not so nice. Every problem solving or trying to solve every problem on your own is nice, but is in the broader perspective not so good, because the question is, how much time are you going to spend on this? While perhaps by asking some help in a much quicker way, this thing could be taken care of. Making bigger judgments. Engineering selected a solid carbide milling system, and you decide, I go for an insert system. That makes everything blown up. And if you see, today I have a problem, and tomorrow I have a problem, and the day after I have the same problem, and every day I do the same remedy to solve the problem, and for the rest I don't do anything with that observation, that is also not right. If you see things are coming back in a systematic way, it's time to communicate. It's time to inform people about that. Professional operators have knowledge of machining, knowledge of tooling, whatever, knowledge of the environment in which they are supposed to operate. They have skills. They know what to do and how to do in certain situations. And they have that disciplined behavior, the mindset. What is my responsibility? What am I doing here? I'm here to stabilize the process, to make minor modifications if needed to make sure that everything which was prepared by engineering functions in reality. I respect the decisions from engineering, at least in the first phase, if I have serious questions about it. In a later phase, through communication, to communicating my observations, I can put things on the table. And in that respect, professional pride for a machining person is should not be that I can change everything, I can solve every problem, but should be more about I can make that the process runs in a stable manner, in a reliable manner. I have things under control, and the outcome is as it was planned to be. We have had a series now with this one included of 4 presentations. There is a 5th one where we are going to take all of this and create a system. But in the meantime, as I said, management is there to define strategies and direction. Engineering translates that into a machining process in a technical perspective. And operations, the operators, the workshop people, they execute and make that things run in a stable manner. If things are stable, leave it alone. If things need some minor modifications, do the modifications, document it and send it to engineering. If major changes are needed for, then you have to involve engineering. That's the role of the operators in the full picture. And when every level does what it is supposed to do, if management takes their responsibility, if engineering does a good job in translating everything in a correct way, and if operations make sure it happens in line with expectations, then we have operational excellence. And that's why I said in the beginning, operators are the last in line, but also the first in line to achieve operational excellence. And professional operators, they have the discipline to apply what is decided by management, by engineering. They monitor the machining process. They watch, they see, they understand. And based on that, they stabilize the process with minor modifications that they can do on the spot, or when major modifications are needed, they have to involve engineering for that. And whatever they see, they communicate to the people before them in the chain what their observations are. For your information, this presentation, if you want to have a copy, as always, of course, just let us know and we make sure you have a copy of the presentation. We also have quite a lot of literature, and perhaps now I can define it a little bit more careful by saying this literature is what an operator needs for the skills. When I see something and yeah, what I see is strange. What should I do and how should I do it? For that, we are quite a lot of pocket guides, as we call it, available for different processes, different situations. If you are interested in those, also please let us know. And before we end this, let's see if we have questions. Yeah, yeah, we have some time. First one is a good one. Somebody is asking, why should I share my improvements with engineering? They don't understand anyway what really happens at the machine. That's a strong statement, first of all. But it's very representative for very often the spirit, the mentality, I don't know how to say it, which I have been fighting for a long time in the machining world. It's too much a bit like they don't understand my job in both ways, and then there is no communication but miscommunication. I would say if you say, yeah, I have doubts to share my suggestions, my observations. First of all, if you make a statement, they don't understand. You know that, or are you supposing that? That's the first thing I would like to give you to think over. On the other hand, the reality could also be that from the other side, with other words, the engineering side, also there people should ask themselves the question, when an operator calls me and says this and this and this, am I open to listen to him? Because once again, yeah, when he's sharing an observation, yeah, I suppose he's not just pulling it out of the air. Another, I hope that's an answer, because yeah, it's very nice to have this question, because that demonstrates again that next to education, next to skills, that mindset, that motivation is so important to have a professional machining expert team, both engineers and operators. Another question, in case that you come to a customer and you found a lack of one of three pillars explained, how could you help as a supplier to solve and close this gap observed? Knowledge. That's I would say that's the easy one. My whole professional career, more or less, I teached, I share knowledge. I always say in my professional career before I was retired, part of the time, 50% of the time I was gaining knowledge, learning myself, and the other 50% of the time I was sharing knowledge, handing it over to other people. So that's the easy part. The skills part also, that is relatively easy. That is helping people achieve, have it in the fingers. Okay, if you see this, yeah, you have to do this and this, and if you do this, you will see that. That's helping people out in reality. Being there to help, and share the why. If I see this, I do this because this and this and this, and give people the opportunity to learn. The third part. Yeah, that's the difficult part. That's about if people, uh, yeah, it's difficult to. Let me put it like this. When I was a junior, when the first year I worked, this part was for me very difficult to help people with, because people said, "What do you know?" Just from university. But the older I get and the more years I had in the field, the more I could talk in a say of sit down and listen. Let's talk now to each other. Let's try to understand what and why and how can we do this together. So I would say, if the pillar which is missing is the mindset, is the motivation, what you need is a very, no, now I was going to say a very old person, but that sounds very negative. Somebody with some mileage on the counter, you know, that can motivate people to work together. But the first two ones, to be honest, are relatively easy. The third one could take some battles to achieve. But over the years, I learned that if you come with the correct arguments, machining people are difficult people. I hope I can say that, and I'm a machinist, so I'm difficult, but not unreasonable. You can always reason with them, but you have to come with the correct arguments. Then there is also a question. Yeah, I hope that was an answer. So the first two ones, easy. Plan for an education. The first two ones, I mean, plan for an education, plan for a training. Sit down, let's do it, share knowledge. Third one takes time to convince. Then there is another, we have some time left. You mentioned respecting engineering intentions. In your experience, what separates an operator who improves the process from one who unknowingly drifts away from the original engineering intent? Knowledge. If an operator needs knowledge to understand why engineering took certain decisions. On the other hand, one could of course also say, engineering needs to communicate, which is also a very true statement. Because that's also a bit of an issue sometimes. Engineering decides, let's go for high feed milling. And if an operator says, why do you select high feed milling? Because my experience, and then he's already stopped, and the engineering says, I decide high feed, and that's what it is. So that's not a correct attitude from an engineering side, which I talked about at previous presentation. But an operator needs knowledge, needs understanding. Why has certain decisions been taken? That's one thing. And the second thing, even more important than the first one, is discipline. This discipline to say, okay, people have been thinking about stuff. People, based on that, came to certain decisions. I have the discipline to respect that and execute. If I have doubts, I bring it on the table later on in my feedback round. I say, okay, you decided this, I execute it, but I have second thoughts because this and this and this and this. That has to come in the feedback phase then. So knowledge and discipline, the discipline to respect decisions, discipline to work together in a team, professional discipline is, in my opinion, what makes the difference between a professional operator and one that drifts into deep space somewhere with certain modifications. One last question. Management keeps talking about process stability, but isn't flexibility more important in small batch production? A very good question, but you are confusing two things here. In small batch production, flexibility is, in the broader picture, that from the beginning, and I look at management now, selections has been made so that a flexible production is possible with not too much time loss during two batches due to modifications which are needed. A very long sentence. What I mean with this is, if you run small batch production, Let's make the example simple. If small batch production means that you machine and steel and stainless steel and titanium, well, management should consider that and start thinking in terms of tools that could be used in all three materials. Instead of an optimized tool for steel, but it doesn't work in titanium, and the best possible tool for titanium, but it doesn't work in steel, and stainless steel is yet another tool, and so on. That is flexibility. And that decision is already early in the process. Stability in small batch production, and in that respect, it's a very good question. It means that flexibility led to a decision by management. We go for one single tool for all three workpiece materials, well knowing that for all three workpiece materials, there could be, from a performance perspective, machining performance, a better tool. But yet, we go for one, having the broad look at machining production, reducing lost times due to tool changes and stuff. The role of an operator then, stability-wise, is watch the tool in process, and if you see the tool is drifting away a little bit, that you correct a little bit. That is stability then. So you understand what I try to say? Flexibility and stability could be a slogan. We are stable in flexibility, or we are flexible in stability. But then now I'm drifting off. It's two different things, and the responsibility for it is in the hand of two different kind of people. Although management has to communicate through engineering to the operators, look, we selected this tool for this and this and this reason, so the operator knows what to expect. And the operator has to communicate back to engineering/management that saying, okay, your selection worked rather okay in steel and in stainless steel, but you know, if it's titanium, I have to halve the cutting speed. Now, that's not a minor modification anymore. That's a major modification. And that needs to be communicated back to management engineering so they could reconsider their original decision. Make sense to you? Seen the time. I stop here with the questions. All the other questions I'll take care of later in the comments and make sure you find the answers there. I hope you found it an interesting session. I hope you are not disappointed. This was not a technical session, and this was not about cutting speeds and feeds and stuff like that. This was about the third pillar mainly of a professional operator. Knowledge is one thing, skills is another thing, mindset is very important. And a last remark, operators, they don't add value because they see what is happening. They add value because they understand what they are seeing and they act accordingly. So this statement once more underlines the importance of good education and good training. Thank you very much for being here. If you want extra information, if you want a copy of this presentation, please let me know. We'll make sure that you have it. We stop now for 2 months, and then we are back in September. And in September, we are going to talk about square shoulder milling. And, you know, square shoulder milling could be that one single machining process where the amount of tools, different tools available is enormously. I don't know, if you do a market research, I think for square shoulder milling, you could find, I don't know, 1 million solutions. And all of them are good. But not all of them are good for you. And whatever we learn now in these 4 sessions, tooling selections are important. Management has to take its responsibility. Engineering needs to make the correct translations, and the operators have to make it work. That thing we are going to apply in the session in September 10th on a specific machining operation called square shoulder milling. How to find out of a million different possibilities that solution which is best for your situation. Thank you very much. I hope you like it and looking forward to see you back.